to look back and do a review here of radial forces and how we deal with radial forces. Okay, so when I have an object moving in a circle, what we're going to do is we're going to break the acceleration into two parts, two components. One component is going to point radially inward. We're going to call that the radial acceleration or the centripetal acceleration. The other component of the acceleration is the tangential acceleration. And that can either point in the direction of velocity, meaning it's speeding up, or opposite the direction of velocity, slowing down. So tangential acceleration is going to speed it up or slow it down, whereas our centripetal acceleration, being perpendicular to the velocity, is only going to change the direction of that velocity to make it go in a circle. So let's go ahead and kind of walk through the steps we would use to solve a problem like this. So let's just go ahead and take an example where I'm whirling a stopper around on a string, and so there is a string attached to some axis of rotation, say my hand, and that stopper is whirling around. So the first step you want to do is go ahead and draw a free body diagram. So here is the stopper. Acting on that stopper, I do have gravity acting down in this case, and I also have tension acting down. I also want to go ahead and identify the direction of AC as inward and positive. So AC is pointing this way and it is positive. That helps me go ahead and generate my equation where I add up all the forces parallel to the radius. So anything pointing inward in the direction of AC is going to be positive. Anything pointing outward would be negative. If anything is at an angle, you will have to resolve it. So in our case, we're going to get tension plus mg equals mac. At this point, we're into the solving process. Now, typically what's going to happen with this AC is we're going to do a bunch of substitutions. So some substitutions available to us. AC is equal to v squared over r. So if I know something like the linear speed, I'm going to make that substitution. Or I can make the substitution omega squared times r if I know the angular velocity of that. There's further substitutions that you might have to do. You might have to say, well, v is equal to 2 pi r divided by the period, or omega is equal to 2 pi divided by the period. You might have to make some more substitutions like that to get things in the proper way that you can solve it. Do be careful though, like in situations where we have tension, we're going to have a T for tension, but we might also have a capital T for period, so just make sure you keep those things straight. But that's just a quick review of how we set up and solve these types of problems.